We're going to look at a new meter from Tesmen. This one's called the TCM300D. This will measure voltage, current, ohms, diode test, even has a temperature probe. It'll measure current without breaking the circuit. It's an inductive loop, and it'll measure AC and DC current. I'm going to check it out for accuracy with my old fluke for checking it out. I think we got another winner here, folks, and the price is pretty darn good. We're going to look at the new clamp meter from Tesmen. In the box, comes with a carry case and a user's manual. Here's the meter. Oh, it's quite small. Runs off of 3 AAA batteries. Now the good thing about that is that, well, it's you can replace the batteries quickly, unlike some meters that are rechargeable, where you have to recharge them. If your battery is low, you're stuck. When you've got replaceable batteries, if the battery goes low, you pop in a new set of Duraleaks, or insert your favorite brand here, and you're off to the races. Batteries are going to go in the back. And here it is in auto mode. To start, I'm just going to peel this plastic off here, because I know it's quite often they're quite glary when you're trying to film it. We're going to put the meter through its paces. We'll test voltages. I'll compare it to my fluke. I've got my breakout cable handy for doing AC current measurements, DC current measurements. So let's put this through its paces, and we'll check it out and see how it works. I'm going to grab my good old Fluke 12 as my reference. I reference everything to my fluke. You know, because it'll be a fluke if it's accurate. Or is it, if it's accurate, it's a fluke? And that's just because I'm not referencing it to other meters that I've tested, just because I want to give it a fair test with the fluke. So first things first, let's get the meter probes unpackaged. Common. And the input. Now by default it's in automatic mode. We're going to put some voltages on here to test it with. I'll get my power supply going. We'll take a look at the voltage on the fluke first, and then we'll check the voltage on this one. So I'll clip the fluke on. This is DC voltage. The fluke says it's 3.89 volts. Okay, so our voltage is exactly the same. If I turn the voltage up, we'll set it to 15 volts. And then we check the voltage here. And we've got 15 volts, 14.99, close enough. This scale here tells you what you're actually looking at as far as what you're looking at, whether it's voltage, AC voltage, DC voltage, etc. Next, we'll check AC voltage. We'll measure the good old power plug. Now the fluke, I've got to switch over to AC voltage. This one will switch over automatically, but with the fluke, 121.2 volts. $120.9 at 60 hertz. So this gives you the frequency as well as the voltage. And of course this one tells you it's voltage. Now you can switch modes by pressing the button. DC voltage or DC current, DC voltage, ohms, continuity test, that's for, right? Diode test, does it beep? Nope, of course not. Millivolts, DC millivolts, frequency, capacitor tester, This is for temperature sensing with the temperature probe, which plugs in. It's just a thermocouple that plugs in the same place. I don't know that I need to show that. I guess I could, but we'll worry about that later. And then this is non-contact voltage and live. So non-contact voltage uses the sensor up top here, I'm sure, to detect. That's live, and that's NCV. If I put it in live mode, then any probe touching live will give you an indicator, right? If I do neutral, nothing happens. If I even touch it with the negative, that's giving me an indication that it's live. And it's high voltage. Non-contact voltage measurement. I'm assuming it's that, but it, oh there we go. It beeped. And I'm not making contact with the live wire. I'm just getting close. And there's probably a sensitivity on this as well. To measure current, you just clip the meter onto one leg, and when I plug the heat gun in, it's telling me that I'm drawing 12.2 amps. So showing about 12 amps on the neutral. Oh, you know what? I'm hitting the hold button on the side there. So I'm wondering why am I keep holding this thing? I'm tapping the button on the side here. It says hold. Okay. I was wondering why it was doing that. 12 amps. And if I go to the neutral, it'll measure the same because you got the same amount of current going back. Right? If I were to clip it onto both of them together, then obviously it's going to read 0 because the current is equal in both the neutral and the hot. So there's no current flow to detect. That is AC current measurement. Now I'll do DC current. I've got a 8 ohm resistor set with 8 volts going through it, actually 8.2 volts. My meter, or my power supply is telling me that I have 1.02 amps. If I clip the meter on here, it's measuring 0.97. That's pretty good. 13.3 degrees Celsius in here. Sounds about right. So it's fairly accurate. It's a couple hundred milliamps off on measuring DC. But for a clamp-on meter, that's very good. Gone are the days where you actually had to break the circuit. Now you can just clip the meter on. So that's current measurement. Put the meter into diode test mode. We'll just grab a generic diode and measure it. Open one direction, put the cathode on the negative, and it shows that I have a 0.7 volt drop. Yeah, if I touch both hands, somebody's going to say that this is going to impact the reading. It's not. Skin resistance is way too high, but just to keep the purists happy, I'm only touching one lead. 0.5 is the 0.59 or 0.6 volts is the drop on this one, and if I bring out the fluke shows that it's probably the same. 0.6. Yeah. The fluke beeps, and the diode is good. I like that. That's one thing I miss, is the other ones don't do that. You'll do your diode measurement, it'll show you your voltage drop, but it does not beep. Same goes for if you're measuring a transistor. Grab a transistor. Here's an NPN. These are just generic transistors that were given to me. Right, 0.6, it's a base collector emitter, so emitter to base and collector to base is 0.6, and in the reverse direction, of course, it's open. That's your diode test. Put in millivolt. If I turn the power supply down to I don't know, 0.2 volts or something, what I can take this thing down to. We'll measure millivolts. So 139 millivolts, and compare it with the Fluke. The Fluke says might help if I put it in DC voltage. Where are we here? There. Fluke says 0.145, and this one says 145.9 millivolts. Any questions? Yeah, the voltage is accurate. Another feature it has is Inrush current measurement. So, in other words, if I keep hitting that hold button. Let's get that out of there. If I set it to Inrush, so I put it into amp mode. So we're going to manually select amps, and we're going to press the select button, AC, A, and press it again. It'll say Inrush. So now what this will do is this will measure the amount of inrush current that flows through the wire while the heater is heating up, because it'll obviously draw more power as it first starts. So when I plug it in, we should get the inrush measurement, which is 12.5. And it holds the inrush. So whatever something is drawing when it first starts, it will hold that current. On the side, there's a button to hold the display. It says H, and if you press and hold, it turns on a light so that you can see what you're doing in the dark. If you're working around an electrical panel or someplace where it's dark, at least it shows you to make sure you've got the wire clamped that you want. And then press and hold to turn it off. Just tap it to hold the display. Finally, I'll show you capacitance measurement. So we're going to select over here to capacitor and discharge the cap. Negative goes on the negative terminal. Someone's going to tell me I'm doing this wrong. I know it, but really the body capacitance is not going to affect it unless I'm touching both terminals. So I've got the negative, and I just touch the positive to the positive terminal of the capacitor, and it will measure how many microfarads this is as it charges up. 472 point, well, 400, yeah, there we go, 469.0. It's a 470 microfarad capacitor. Right there, 470. So that will measure capacitors. If I go to a 1000, same thing. We'll short it out to make sure that it's fully discharged when we start. Negative lead on negative, positive lead on the positive. $1,099, because it switches over to millifarad. So 1.095 is like 1095 microfarads. So you can measure your capacitors. They have to be out of circuit to do this. Obviously, it's not an ESR tester. It's just a regular standard volt ohm meter with capacity and current measurement. We're seeing a lot of these new meters that have the current clamp on them now, which is a nice feature, especially if you're using them in the field or using them for electrical work. This is great. This is really the only thing you need. If you're doing home electrical work, working on your own home system, and you're trying to balance your panel, for example, this will show you what each branch is drawing when you're operating appliances and so forth, which is great for balancing the load. Electricians would like this, and it's a great little meter. I think it's, seems to be pretty rugged. It's plastic, but the display seems to be well protected. I push on it and I'm not getting really any distortion, so it's got a protective cover over the screen. Looks to be pretty good. You know, I think for the value, you're not going to find one that's going to do better than this one for the cost of it. Now, I've been using one of these meters, not this one. I've been using their cheap, like $15 meter at work for doing alarm work, and it's so simple. I'm using it mainly to determine whether a power supply is working for a camera, or whether there's enough voltage at a doorbell circuit for a doorbell camera, and that type of stuff, and checking continuity. And it's real simple. I reviewed it a while ago. It's the very basic, like the cheapest meter you'd ever think, but it gets the job done. It tells me everything I need to know, and it just has basically 3 buttons on it. Power, I think it's got power, hold, and light or something. It's got 3 buttons on it. I turn it on, make my measurement, and turn it off. This is going to be another one that could very easily find its way into my work truck, just because it's got everything on it that I need. I don't need the current capability, but it's got everything else that I would really ever need in one compact meter. On here, it's a category 3 environmental conditions, 600 volts. Working environment is 0 to 40 degrees Celsius, which is 32 to 104 Fahrenheit. Storage environment minus 10 to 60 Celsius, or 14 to 140 Fahrenheit. Remove the batteries if you're over 70% relative humidity for storage. Maximum voltage allowed between jacks and earth ground, 600 volts. 6,000 counts on the display, OL displayed if you're over range. It's got a polarity indication, and it has a low battery indicator. And that is basically, I think, pretty much it. Do some measurements of resistors. This is a 2.7K resistor I've got here. Fluke says it's 2.89 because it's a carbon resistor and they drift. 2.89 on the Fluke, and on the Tesmen, 2.893. Let's grab another resistor here. What is this one going to measure? I'm just grabbing random resistors. This one is 1K. Measures 1.02. Go over to the Fluke. 1.02. Another random resistor. Fluke says it's 7K. $7K. I see no issues with the accuracy of this Tesmen over my classic Fluke, which is old as the hills, but probably still pretty accurate. Let's pull it apart and get it look and see how well it's built. They say they're good to 2030. Yeah, right. I think by 2030 these batteries will be leaking whether they're used or not. If they live up to Duracell with their latest batteries that they've made, because I've certainly seen enough Duracells over the years that have prematurely leaked. Back should just slide off this thing. Hopefully things won't go flying. There we go. There is the meter itself. Oh well, yeah, they've milled down. Looks like they've milled down the numbers on the IC. That little crystal is it's glued down. Good. That's glued down so it doesn't get banged around. What a lot of these manufacturers are doing now is they're just milling off the top of the IC. And they're doing that to protect their IP. This is probably a pretty common processor. I'm sure the program is probably stored on that. That's going to be EEPROM, I'm sure. But this is probably a pretty common chip. And because of that, they're trying to keep their IP private, which is an old trick that they used to do and they still do. They take the number off the IC because it's probably a very common IC. It would stop people from copying the board, buying the part, and dumping the program on the EEPROM, and then flashing another EEPROM and making a clone. So what a lot of companies used to do, and apparently still do, is they remove the number from the chip. If this was a custom chip, right? If like Fluke, for example, would have their own custom chips, so they would care less if you knew what the number on the chip was, because you can't buy it because they're making it themselves. So they don't generally take the numbers off. But when companies are making a product and they're just using off-the-shelf parts, and generally these companies would do that to keep the cost down, they try to at least protect their design a little bit by milling the top of the chip off. Battery connections just go through those springs on the board here, one there and one over there. Makes it very simple to remove the back and put it back on. Anyway, as I previously said, I think this is a winner, and for the price, I don't think you can go wrong on this meter. If you want a general basic meter that will do all of your voltage and current measurement requirements, then this meter is probably going to be just fine for you, and you'll likely see it in use on my bench along with all the others. And to answer the question, no, I have not retired my Fluke. I'm just using other meters now because some of the other ones are a little more convenient. They have some features on them that the Fluke doesn't have. There, see, it just booted up. And that is that. And my Fluke needs new probes. The one thing I haven't shown yet is the thermocouple. We plug in the thermocouple into the bottom and turn it to temperature here. It'll show you both Fahrenheit and Celsius at the same time, or centigrade if you're one of those people that prefer to call it centigrade as opposed to Celsius. We're going to just melt some solder on here and dip this probe into the solder and see the temperature of it. So I'll just melt some molten solder on here on my bench. Why not? And then we'll dip the probe in the end of the solder, and we'll watch the temperature shoot up. The iron is set at 700 degrees. It's measuring 681, which is to be expected because the tip temperature is actually hotter down here where the thermocouple is. It's going to be cooler at the actual tip where you're soldering. Anyway, it's pretty close. Let's say the iron is set for 700. But again, as I've explained before, the thermocouple that measures the temperature is actually down here. It's not on the tip, so the temperature is going to be a little bit colder here. Like I know if you use the longer tip, there's a longer tip, they tell you to increase it by 50 degrees. So the fact that it's measuring, what was it, 685 or something here, that's probably correct because it's 700 down inside the tip itself. So I would say that that's a pass. It's accurate for temperature measurement as well. Okay, that's about all I can show you on this meter. I'm going to end it now. I'll put the link in the description. Thanks for watching. We'll catch you in the next one.